Assalamualaikum YouTubers, welcome back to SLK Tools. Here in this section, we'll be just designing a square tie column. Alright, and of course, this is RCD, or reinforced concrete design. So we'll design a square tie column, right? And this is of course the simplest thing in design, I think. Alright. So actually a few friends just demand the design of a square column. That's why I'm just doing this topic today. Alright. And the design of a square tie column is quite simple and straightforward. But how can you design if you don't know about different requirements of columns? Alright, so I just want to spend a little time with ACI 318 requirements per columns. Alright, this will of course helps us in design, okay? And the first thing I just want to explaining is the percentage of steel. And according to ACI 318, the percentage of main steel must not be less than 1%, nor more than 8%. Alright, this is a good ratio, right, for design. Okay, so actually the percentage is taken of all gross cross section area of column, right? And this is which mean AST must not be less than 1% of gross cross section area, and of course AST must not be greater than 8% of AG, or gross cross section area, right? And of course, at least 4 longitudinal bars must be used within rectangular or circular ties. And this is of course just little different for spiral, which is always kept, or at least 6 longitudinal bars must be used within spiral ties. These are just ACI 318 requirements per column, right? I want to spend a little time with some additional requirements only per tie columns. And then I'm just coming back per spiral columns, right? These are just some additional requirements. And the first thing per tie columns requirements, I just want to explain the minimum tie size. Of course, it's number 3 bar, right? Per longitudinal bars up to number 10. And this can be taken number 4 bar per longitudinal bars larger than number 10. Alright, and this is a good ratio, I think. And commonly we also use this, guys, so this is the good requirement, right? And the next thing is just the minimum tie spacing. So the minimum tie spacing is the largest of these two, 1 inches or 1 main bar's diameter. Alright, so the largest of these guys can be taken for minimum tie spacing. What about the maximum tie spacing? Of course, it is just the smallest of these 3 guys. The number 1 is 48 tie bar diameter, of course. So 48 times diameter of tie bar. Second, 16 times main bar's diameter. Alright, the first thing was just tie bar diameter. The next thing is just the main bar's diameter, right? And the third one is just the least dimension of column in cross section, right? Of course, the length is always greater than, right, than the both dimension of its cross section. And this is of course square column, so the cross section is uniform, right? One side and another side are equal, right? So the maximum tie spacing is just the smallest of these 3 guys. Alright, these are good requirements, I like them. And the next thing is the spacing of main bars. According to ACI 318, no main bar can be located more than 6 inches from another bar. Alright, which means the maximum spacing is just 6 inches. Alright, the spacing cannot be just greater than 6 inches. If you keep this guy just less than 6 inches, no problem. Alright, just look at this picture, which means the distance must be kept less than or equal to 6 inches, which is just the spacing between main bars. In this section, just look at this guy. The maximum distance between 2 bars is just 6 inches, right? So this is a good requirement. And these requirements are just enough for design of a tie square column. I want to come into some additional requirements just for spiral column. Alright? And the first thing is just the spiral may not have diameter just less than 3 over 8 inches, of course, which means number 3 bar can be used or just larger. Alright, as it must not be less than 3 over 8 inches, and 3 over 8 inches is just of course number 3. Alright, if you keep this guy just larger than number 3, no problem, okay, but cannot be kept just less than number 3. And the clear spacing of spiral must be just between 1 and 3 inches, right, which means the pitch, and the pitch can be defined as the distance between two turns of spiral. Alright, now if you know about these requirements, the design is of course quite simple, straightforward. But I don't want to come into design now. I just want to analyze a simple square column based on ACI codes, and I'll check the column is okay or not, right? So are you ready? Of course you are ready. I know it. Okay, so here is an example. Oh, of course it's an example, and we are just demand to find the design axial load or the design axial load strength for square tie column. The strength of concrete is just 4 KSI, which means FC dash. We call this guy FC dash or FC prime, okay? And the Fy is just the strength of steel, which is 60 KSI, right? Kip per square inch. KSI is just kip per square inch. We are also demand to do little detailing check for the column. But where is the column? It's here, of course. This is just a square column, 18 by 18 inches. The concrete cover is 2 inches. The tie is number 3 at the rate of 6 inches. And the main bars are just 8 in number, and number 9 are used, right? So everything is given, everybody okay. I'll just come straight into solutions. In the solutions, my parameter, the column parameter are just FC prime, Fy, B equals H, because this is just a square, which is 18 inches. And AST, what do you think about AST? Area of steel. Just look at over here. We have 8 number of bars, right, which are just number 9 bars. And the area of number 9 bar is of course 0.999 blah 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 square inches, which can be calculated using the area of a circle, right? And this formula pi r square is just equal to the area of a circle, and the bar is just a circular bar, right? So plug and check in this guy, you can get 0.99 something square inches of 1 bar, and we have of course 8. And the 0.99 is just of course equal to 1 square inches, right? And this is quite simple. So I can say we have AST equals to 8 square inches. Alright, if you are not clear, no problem, just type in comment and ask a question. I'll reply you, okay? And the parameter, the design capacity is just pi 0.81, and the theta is 0.65. And of course these guys are just per tie columns, not per spiral column. Alright, we'll also explain these guys in spiral column when we do the design of that guy on that time. Okay, now we are just passing the design of square column. So everything is given now. I'll come just into solutions. The first thing, my first approach is just to design axial load. And for this, I have a nice formula, right? Theta of En equals theta alpha, 0.85 times Fc prime, Ag negative AST plus Fy AST. Plug and check in, you must get alpha. Where is it? It's here. Oh, it's theta, of course, 0.65. Plug this guy in this formula. And the alpha is just 0.8. So plug this guy over here. Of course, we have 0.85. Fc prime is just 4 KSI. Ag, what's Ag? Of course, it's 18 by 18 because it's a square column. So Ag is just 3 to 4 square inches. Plug this guy over here. Negative AST is just 8 square inches, plus FY is just 60 KSI, and the AST is again 8 square inches. When you do little mathematics with this guy, you can get the design axial load strength of this column equals 808.228, which is almost equal to 808 kips. And this was just our first approach. My next approach is the detailing check. Is the column okay or not? Alright, so let's do the detailing check for this column. This column has been designed by someone I don't know, but I want to check the column is okay based on requirements or not. Alright, and the first thing I want to check the steel percentage, which is of course AST divided by AG. Alright, this will give me the percent of steel and the percentage of main steel. Right, AST is given as 8 square inches, and AG is of course 3 to 4 square inches. You can get 0.024 digit. Okay, there is no unit with this because this is the ratio of the same units. Of course, when you multiply this guy with 100, you can get 2.4%. And according to ACI 318, the percentage is just 1 to 8%, right? Which is between them, right? So we are okay here, yes. And the next thing is the number of bars, which is 8 bars. Alright, these guys, when you just count these black dots which represent the main steel bars, are just 8 in numbers. Just look at our here. And according to ACI, what's the minimum requirement? At least 4. Of course, this is greater than 4. So we are also okay over here, right? Next is the minimum tie size, number 3. And look at over here in the column, we have of course number 3. So we are also okay over here. And what's the minimum tie spacing? Of course, it's just 1 inches, right? Because here we have number 9, which is greater than 1 inches. So I'll take 1 inches. And we have 6 inches center to center. So which is greater than 1 inches. We are also okay over here, right? Now I'll come to the maximum tie spacing. The maximum tie spacing, of course, you know, are just the smallest of 3 guys, which is the first one is just 4/8 times diameter. Plug this guy over here, 4/8, and the diameter, just look at over here, it's number 3 bar, right? Which means 3/8 inches. Do little mathematics with this guy, you can get 18 inches. Next, we have 16 times diameter of main bar. So 16 times the diameter, we have number 9. So 9/8 inches. You can get 18 inches again. And the next thing is the least column dimension. In a cross section, we have only 18 inches again. Yeah, and this is really good. I like it. So the maximum tie spacing is 18 inches, of course. And what we have just 6 inches, which is less than 18 inches. So we are also okay over here. And the next thing I want to just check is the spacing of main bars. Do you remember it's the maximum spacing is just 6 inches? I remember, yeah, of course. According to ACI 318, it's 6 inches. We must need less than or equal to 6 inches, of course. Just look at our hair. The size is just 18 inches. I'll subtract 2 times concrete cover per one side and another side. And the concrete cover is of course 2 inches. So negative 2 times 2. I'll also subtract 2 times the tie diameter per one side and another side. And the tie diameter is just 3/8 inches. Alright, because we have number 3 bar. I also want to subtract 3 main bars because we have 1, 2 and 3 in this sequence. Alright, and the diameter of this guy is number 9 inches, which is of course 1.125 inches, right? So 3 times 1.125 inches just for these 3 main bars. Right, and we'll divide this guy by 2 because we have 2 spans, right? we are just checking the distance between these two bars, and we have the spans equals 2. So I'll divide this guy by 2. Do little mathematics with this guy, you can get the spacing equals 5 inches. Alright, which is of course less than 6 inches, and the maximum value is just 6 inches, and this guy is just little than 6 inches. It means we are also okay over here, right? What now? So the column design which you are just seeing on the screen is okay. Okay, yeah, it's okay. So we are done over here, and I'm just little tired, okay? I don't want to design the column today. Actually, I'll design the column on next Monday, right? So just wait for that. We'll design the column in the next lecture. Thank you for watching. See you next time. And what? Nothing. Wassalam.